Well, to find the possible point of inflection, well, we have similar way as the critical number does. So f double prime of x equal to 0, or it's undefined. Well, when it is equal to 0, we get the numerator equal to 0. That's it, we get x squared equals to negative 80 over 60. Right, we have no solution. Undefined where the denominator equal to 0, that is, we have seen from the first derivative, not in domain. Right? So we don't have any value that are positively the point of inflection. And we have sealed the result of f double prime already on the left. Which technically we're looking for the concavity interval is just build the table for the naturally separate by the domain. Right, 3 parts of the test value, the sign of f double prime, and the shape of f. Right, that is what we see in a previous chapter. Right, the test value we can take well, negative maybe 3, 0 and 3. For f double prime that is negative, maybe we'll take 20 out, that's x squared plus 3x squared plus 4. Well, the numerator is always negative. It depends on the denominator of what it is, right? So if we put negative 3 in, that's 9 minus 4, that's positive. Total, that's negative. If we put 0 in, that's 0 minus 4 is negative. Cubic is also negative, that's positive. And the last part, the negative over 2 in, the 3 in, that's 9 minus 4 is positive. So what we get is concave down, concave up, and concave down. Right, so we get a table, a short one. There's no point of inflection, and the table we have from negative infinity to negative 2, negative 2 to 2, and the 2 to infinity, as we showed before, is concave down, concave up, and concave down. Right, so 2 tables already shows, one shows in about the monotonicity, the other one shows about the concavity, that we are able to build them together, right? The interval from left to right, negative 2, 0, and 2. Negative 2 to 0. 0 to 2 and 2 to infinity of the 4 pieces, right, for f prime and f double prime, what it looks like, and we'll finally wrap up of the function, how it looks like. Well, we get function is decrease, decrease, increase, increase, at negative infinity to negative 2 and so on. Function is concave down, before negative 2, concave up, and concave down. Right, so we get the full step, right? The 2 pieces. As for concave down or concave up, that's increased part and decreased part. We take part of it, that it is decrease, decrease and concave down. So we have decrease and concave down. on the interval negative infinity to negative 2. Decrease and concave up on the interval from negative 2 to 0. Increase and concave up from 0 to 2. And increase and concave down from 2 to infinity. Right, so that's our shape of 4 pieces of the curve. So finally, I wrap up together of all the information we had seen. The graph. Negative 1, negative 2, positive 1, positive 2, 3, 4, 5. 1, 2, maybe 3, 4, 5. Negative 1, positive 1 for the x and y axis. Right, that first thing we see is the x-intercept at negative 3, 0, and 3, 0. Y-intercept is 0, 9 over 2. That is 0, 9 over 2 is our y-intercept. Negative 3, maybe we'll put it on here. Negative 3, 0 is our x-intercept. And 3, 0 is our x-intercept. We also have the vertical asymptote at x equal negative 2 and x equal positive 2. Right, that's a vertical asymptote. And the horizontal asymptote at y equal 2. Right, the information for the negative and the positive. And then finally we draw the piece of the curve. Well, we see from left to right that's decrease and concave down. So for the left piece, maybe use the purple. Right, that's decrease and concave down. I pass through the x-intercept, go close to the point. And from negative 2 to 0, that's decrease and concave up. Then increase and concave up. Finally, increase and concave down. Right, so to be clear, that is our 3, 0 to be x-intercept. We do not have any point of inflection. The point 9, 0 is not only the y-intercept, but also the relative minimum. Right, that is our curve. Then at the end, right, we can mark the range, have some space, maybe over here. Range to be negative infinity to 2, or can take union 9 over 2 to infinity, right? And has a gap, then go up to 9 over 2, goes all the way up. Now we sealed all the information on the left side. We have to wrap up everything as a table to get the shape of the curve. As we graph it, we should be agree with what it is. First of all, the intercepts, then the asymptotes, make them clearly what they are. And then based on this table, we get the curvely change from those. Then at the end, mark the relative extrema and the point of inflection, right? Then finally, observe the graph. Now number 2 is actually able to take, so we get the range from negative infinity to 2 and from 9/2 to infinity, right? At the end we get the range. So that is the curve sketching. We will see more example of curve sketching next time. We have actually 4 examples. That's our first example, which is about very detailed what they looks like. Right? But still we didn't see the point of inflection, but at least we see the accurate curve of what is supposed to be for this function. Right? So thanks for watching. I'll see you next time.